All right. 4.6. Mixed numbers and improper fractions. Let's see here. Fairly simplistic. All right, let's go. Let's see here. I want to make sure everything we're covering today. All right. First of all, we need to know the difference between mixed numbers and improper fractions. Okay. An improper fraction an improper fraction is a fraction where the numerator top number is larger than the denominator. Bottom number. Okay. So, in other words, 5 over 3. That would be an improper fraction. Okay. 9 over 2. That would be an improper fraction. 25 over 3. That would be an improper fraction. Okay. All those are improper fractions because the top number on all of them is larger than the bottom number. Okay? Now, so if an improper fraction is where the numerator, the top number, is larger than the denominator, then a proper fraction is where the numerator is smaller than the denominator. Okay, proper fractions is what we're used to dealing with. 2/3, 3/4, 4/5, 7/10, 11 over 35. Those are all proper fractions. Yep. Great.
So would, like you said, 25 or 25, that would be improper fraction.
25 over 25. Realistically, I guess, but 25 over 25 is what? 1. Okay, so I don't consider it as an improper fraction, but it has to be something. It's obviously not proper, so it has to be something. But I would consider that as 1 because it's just 25 over 25, 2 over 2, 3 over 3, 4 over 4. All those are just 1. So I would classify them as really a whole number because it needs to be reduced to a whole number. But the same thing can be said here because every improper fraction can be reduced to a mixed number or whole number. Okay? For example, if we had the 5 over 3, so we're looking at changing improper fractions to mixed number or whole number. Okay? Not real hard to do it. Let's take our example, 5 over 3. We simply take 3 and divide it into 5. 3 goes into 5 one time. Be 3, remainder 2. Take the 2, put it over the 3. So that is 1 2/3. And that is what 5/3 is as a mixed number or whole number. Okay? The other one we did 9 over 2. 9 over 2, it's always dividing the bottom number, the denominator, into the top number, the numerator. So 2 goes into 9. 2 goes into 9 4 times. Be 8. Remainder 1. Take the 1, put it over the 2. So 4 1/2. Okay, what was the other one I gave you a while ago? 25? 25 over 3. 25 over 3. We divide 3 into 25. 3 goes into 25 8 times, be 24. Remainder 1, put the 1 over the 3. So 8 1/3. Okay, let's say we had this one. Let's say we had 22 over 2. Well, 22 over 2, we divide 2 into 22. 2 into 2 goes once, remainder 0. Bring down my 2. 2 into 2 once, be 2, remainder 0. So 11. Yeah, that's pretty easy. No, it's realistically, it's that simplistic. And it doesn't take you a lot. A lot of times, if I feel like if we've got a handle on it, a lot of times I'll even cover this lesson. But I know we got enough new people, and we probably needed to cover it just to make sure that we get it done. Now, mixed number. A mixed number is a number that has a whole number and proper fraction. Okay, mixed number is a number that has a whole number and a proper fraction. It's not a, we don't name it any either one of those. We just name it 7th grade math. Now, in this class we will cover all the 7th grade book and also cover the first 3 chapters of algebra book. So that's why we move so quickly. All right, now mixed number. Mixed number is a number that has a whole number and a proper fraction. We just had them. Okay, these are all right here. Those are all mixed numbers. Okay, obviously 11's a whole number, not a mixed number. Okay, so a mixed number, if you have the mixed number, let's say 3 5/7. Okay, once again, the definition, it has a whole number here and a proper fraction. Okay, proper fraction meaning that the numerator is smaller than the denominator. Now, to change a mixed number to an improper fraction. Okay, to change a mixed number to an improper fraction, let's just use the one example I gave you, 3 5/7. Okay, you're going to take the whole number 3 and multiply it by 7. So 3 times 7 is equal to what? 21. Then I'm going to take 21 and add the numerator to it. So I'm going to take 21 plus 5, which is 26, and then I put it over 7. Okay. So the steps would be, first of all, multiply the whole number by the denominator. Step 2. Add the numerator to the product that you have in step 1. Step 3 is take the sum from step 2 and place it over the original denominator. Okay, so step 1 was that right there. Step 2 is that right there. Step 3 is that right there. So let me get an example out of the book here on this one. Let's see. 4 5/16. 4 5/16. So step 1, 4 times 16. What is 4 times 16? What? Yep, 64. Step 2, take the 64 and add the numerator to it. 69. Take this, step 3, and put it over the original denominator. 69 over 16. Okay, once again, this was the whole number times the denominator. This is the sum, this is the product plus the numerator. And this is the sum over the original denominator. Sling?
Okay, so let's say we have
8 over 4?
Yeah, if we do
No. Because if you reduce 8 over 4, first of all, you would have to reduce it down to 2. And you'd be back at your original number. Like, for example, if you took that philosophy, 69 over 16 you would need to reduce. Well, 69 over 16 is going to reduce back to 4 5/16. So you'd end up getting from there to there. Now, the only way that what you're talking about could happen is if they gave you an original fraction that wasn't reduced. For example, let's say they gave you 4 and 2 over 4. Okay? They're not going to do that. Okay? They're going to give you that fraction would be 4 1/2. That's what they're going to give you. They're not going to give you a fraction that hasn't been simplified to begin with to change from mixed number to improper fraction. Okay? Because all mixed numbers, for them to be true, they're mixed numbers, they need to be in simplest form, or they need to be reduced to lowest terms before you call them a mixed number. Okay? Any other questions? Okay, let's look at another one. I'm going to give you 2 different ones here. Not when you're changing it to improper fractions, no. So we have 8 and 6 over 7. And I want you to change that to an improper fraction. Okay? And then we have 107 over 13 that I want you to change to a mixed number. So we want 8 and 6 over 7 as an improper fraction. And we want 107 over 13 as a mixed number. All right. So who has the improper fraction? Grant. 52 over 7. 62 over 7, yes. 62 over 7. Okay? Because we have to take 8 times 7, which is equal to 56. 56 added 6, so 56 plus 6 equal 62. That's where you get the 62 over 7. Okay, now, what about the mixed numbered? 107 over 13. Celine. 8 and 3 over 13. Let me see. 24. Yep. 113 into 107. The 8, 104. Remainder 3. Take the 3, put it over 13. So 8 and 3/13 is the other one. All right. Now, let's look at this problem. 22 over 3 and 7 1/4. Okay. 22 over 3 and 7 1/4. Okay, they want us to tell which one is greater, less than, or equal to. Okay. Well, first, we need to change this one to a mixed number. What is 22 over 3 as a mixed number? Seven and what? 7 1/3. So 7 1/3 compared to 7 1/4. Okay. Well, which fraction is larger, 1/3 or 1/4? 1/3. 1/3 is larger than 1/4. Okay. So 7 1/3. So 22 1/3 would be larger than 7 1/4. Okay. Think about it logically. If you divide $1 up into 3 parts, even parts, that would be 33 1/3. If you divide $1 up into 4 equal parts, that's 25 cents. Obviously, 33 cents is more than 25 cents. Okay? And so that's why it's larger. Okay? Everybody open your book to page 188 and let's look at number 12. Okay. Number 12, they've drawn an object, two objects, and it says write an improper fraction and a mixed number to describe the model. Okay? So, how many little squares are in each big square? On number 12, how many little squares are in the one big square? 12. Okay? So, there's 12 in each object. Okay? So obviously they've colored in the first object completely, right? So that would represent what? 12 over 12, right? Or 1. 12 of the 12 boxes are colored in. Okay, how many boxes are colored in on the second one? 7 out of 12. Okay? So the first box, you have the first box that's colored in, and that represents 12 over 12. You have the second box, and only part of it's colored in, and that represents 7 over 12. So, what would be the mixed number then that would represent this model? No. What mixed number? Huh? No. What mixed number? What does this represent? What does 12 over 12 represent? Right. So there's your mixed number, 1 and 7/12. Now, to make an improper fraction, really all I got to do is add 12 and 7. 12 and 7 is what? 19 over the original denominator. So that's your two answers. Okay, this is number 12. Okay, that's how you would come up with your two answers. Okay. Now, I'm going to have to change your homework, so I forgot there's part of this that came from... Johanna, did you have a question? How'd I get 1? I've got one whole box, which is 12 over 12, that's colored in. Okay, so they've got all of this colored in. Be like if there was 12 slices of pizza in that box, and I gave you 12 slices, then you would have that one whole pizza. Okay? And so that's where we came up with the 1, because 12 over 12 is 1. Okay? And then the 7 over 12 is because 7 of the pieces of pizza have been taken out of the box, leaving me with 5 pieces left that haven't been eaten. Okay? And so that's where we came up with a 7. So to see how many slices of pizza were taken out of the boxes, we'd simply take 7 and the 12, and that's how you would get 7 plus 12 would be 19/12. Or one whole box and 7 slices out of the other 12. Okay. I need to change the homework. It's not 1 through 42. I'll have to make sure I tell them, because I forgot part of this we haven't covered yet because I switched chapters. We're going to go 1 through 35. So 4.6, 1 through 35. Okay, we got quite a bit of time. You got about 15 minutes left, so you can work on that and get some of it done.